Welcome to Shanti-Peace for Mathematics. In the previous video, we have learned regarding Rolle's mean value theorem, which states that let f be a function from ab to r, where ab is a closed interval, which satisfies the following conditions. The first one is f is continuous on closed interval ab. The second one is f is differentiable on open interval ab. The third condition is f of a is equal to f of b. Then there exists at least one point, one c in between ab, such that the derivative is equal to 0. The first derivative at that point is 0. The geometrically we can say that if the smooth curve is there and its y coordinate of the point is same, then there will be a one point where the tangent of that curve is parallel to x-axis. In this video, we'll learn certain examples based on this Rolle's theorem. So let's start with these examples. The problem is discuss applicability of Rolle's theorem for the functions. The first one, f of x is equal to x square. The second one, or I can say g of x. G of x is equal to mod x in the interval -1 to 1. Here the interval is 2 to 3. So your x belongs to 2 to 3. And the third one, h of x, will be 10x in the interval 0 to pi. So this way the functions are there. We have to check whether we can apply a Rolle's mean value theorem onto these functions or not. So for the first example, we just say that f is a function and it is a continuous function on closed interval 2, 3 because it is a polynomial function, x square function. We know that it is a continuous as well as it is the differentiable on open interval 2 to 3. And what you can observe is what is f of 2 is 2 square will be 4 and f of 3 is 3 square which is 9. So what you can note here is f of 2 is not equal to f of 3. But into the Rolle's mean value theorem, it has to be the f of a and f of b value has to be same. Here the value of a is 2 and value of b is 3. So that means the third condition is not satisfying. So therefore the Rolle's mean value theorem is not applicable for the function f. So what I can say, therefore the Rolle's theorem is not applicable to the function f. Second example is about gx, where you have given that g of x is equal to mod x. We know that the mod x function is a continuous function. So the function g of x is equal to mod x, where x is between -1 and 1, is continuous, but g is not differentiable at x is equal to 0, and 0 belongs to in the interval -1 to 1. Due to the reason is limit of h tends to 0 plus g of 0 plus h minus g of 0 upon h, which you can say it is limit h tends to 0 plus mod of h upon h which will gives you, if h is positive, it will gives me 1, and on the other side limit h tends to 0 minus g of 0 minus h to 0 of 0 upon h, which have limit h tends to 0 minus, that is a left hand limit, mod of h upon h will gives you minus 1. Therefore, we can say that this g function is not differentiable at this point x is equal to 0, and hence we can not apply a Rolle's mean value theorem onto this function g also. So therefore we can say that the Rolle's theorem is not applicable on g. The third function which we have given is this tan x, that is h of x is equal to tan x in the interval 0 to pi. So the function hx is equal to tan x here into the interval, close interval 0 to pi is there. But one should note that the function h is not continuous at the point x is equal to pi. So we should know that h is not continuous at x is equal to pi by 2, because we know that tan pi by 2 is infinitive, it does not exist. And if you can look at the graph of the tan function, this is the my x is equal to pi by 2, then the graph of the function is this, that we know it goes to infinitive. So that's why this function h is not continuous at the point pi by 2, which is in this interval. So that's why here also we cannot apply a Rolle's mean value theorem. You can write the detail in your words here. Let us go for the next example. The verify Rolle's theorem for f of x is equal to 2x cube plus x square minus 4x minus 2. So the question is to verify whether the Rolle's mean value theorem is applicable, and whatever the c we got, it has to be into the given interval. So here I am taking the interval is if x is between minus root 2 to root 2. This is the interval we can take. And as this is a polynomial function, it's automatically f is continuous on close interval minus 1 by root 2 to 1 by root 2. F is differentiable because every polynomial function is differentiable everywhere, so in particular in this interval also. And the third condition that we need to verify whether the f of root 2 and f of minus root 2 will have a same value or not. So we should check what is f of root 2. That you can find out, that is 2 into 2 raised to 3 by 2 plus root 2 square will be gives you 2, that is 4 into root 2 minus 2. This 2 will get cancelled out, and you just observe that this is nothing but the 4 into root 2 plus, then this is minus 4 into root 2, so it will be 0. And f of minus root 2 is also having the 2 into minus is there because of cube, so it is 2 raised to minus 3, 2 by 3, and x square is there, so it is minus root 2 square, but square will have a positive sign. Here it will have a plus 4 root 2 minus 2. This quantity will get cancelled out, and this quantity with plus and minuses. So we can say that f of root 2 is equal to f of minus root 2 equal to 0. So hence this f is satisfies all the conditions of Rolle's theorem. So we can be able to apply the Rolle's theorem. So therefore, by Rolle's theorem, what we can say, there exists at least one C, it is in between open interval -1 by √2 to √2, such that f dash of C equal to 0. Now we have to verify whether this f dash of C is equal to 0, that C is will it be in this interval or not. So for that, what is f of x we have given? It is 2x cubed plus 2x square minus 4x minus 2. This is the function we have. What is f dash of x we have? The f dash of x is 6x square plus 2x minus 4. And f dash of x is equal to 0 will gives you 2 will get common out from this, that is 3x square plus x minus 4 equal to minus 2 equal to 0, because I got 2 common. So that's why this is factorized as x plus 1 and 3x minus 2 equal to 0. And this will gives you x is equal to minus 1 and x will be 2 by 3. Once you know that this both value x is equal to minus 1 and x is equal to 2 by 3, both of them are belongs to in this interval minus √2 minus √2 to √2, and therefore we can say that the Rolle's theorem is verified. That means we have checked whether we can apply the Rolle's mean value theorem, and those points where the f dash is 0, those points are lies in this interval. Let us have one more example of a same kind. So the question is again, verify Rolle's theorem for the function x cube minus 4x for the interval minus 2 to 2. So given the function, again it is this function is polynomial function, so we should write that f is continuous on closed interval minus 2 to 2 due to the polynomial function. F is differentiable function on open interval minus 2 to 2. The third one is, what is f of 2 is there. The f of 2 is 8 minus 4 into 2, that is also 8. So that will gives me 0, and f of minus 2 will be minus 8, and due to this minus sign this will be plus 8, and that will be 0. So therefore f of 2 is equal to f of minus 2. So therefore this f is satisfies all conditions of Rolle's theorem, and hence we can apply a Rolle's theorem, and hence therefore there exists at least one C in interval minus 2 to 2 such that f dash of C is equal to 0. Now we have to find out what is this point C is, and whether that point C it is lies in this interval, that we need to check. So now what is your function f of x is given to us is x cube minus 4x. So therefore it is f dash of x will gives you 3x square minus 4, and f dash of x is equal to 0. We have to find out those points where which is satisfying this. So that's why f dash of x is equal to 0 will gives you 3 square minus 4 equal to 0, will gives you x is equal to plus or minus 2 by square root of 3. And if you use the calculator and if you find out the value of this one, that will be plus or minus 1.155. You can check. And 1.155, both this value are belongs to the interval minus 2 to 2. So hence we can say that the Rolle's mean value theorem is verified. The Rolle's theorem is verified because this value which we got, it is lies in this interval. I can give you one example here to discuss or let us discuss here that f of x is equal to sin x, where x belongs to 0 to pi. The question is to verify the Rolle's mean value theorem. Now I am not writing all the details here. You should write by in your words that f is continuous on the interval 0 to pi because it is a trigonometric function and it is a sine function. F is differentiable on open interval 0 to pi, and the third condition is what is f of 0? It is sine 0, and we know that sine 0 is 0. F of pi is sine pi, and we know that sine pi is also 0. So therefore f of 0 is equal to f of pi. So hence this f is satisfying all the condition of Rolle's theorem. Hence we can apply the Rolle's theorem here, and therefore there exists at least one c is in interval 0 to pi such that f dash of c will be 0. But what is f of x here? It is sin x. F dash of x will give you cos x, and which implies f dash of x is equal to 0 implies that cos x is 0. But cos x is 0 will implies that x will be, there are many values of x is possible now. For example, plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, all those values where this cos is 0. But among this value, this theorem or this statement is saying that at least one, it has to be at least one c which is lies in this. So we have the pi by 2 which is belongs to 0 to pi is there. So therefore we can say that the Rolle's mean value theorem is verified. Let us have one more example that, and I can give you this example is to work out with you guys that f of x is equal to, we can verify whether we can apply a Rolle's mean value theorem for this function x square plus ab upon x into a plus b, whether we can apply a Rolle's mean value theorem for this for the interval ab. Okay, so you can just check that whether this we can apply a Rolle's mean value theorem on this. We have to check whether this function is differentiable, whether this function is continuous. It is obviously continuous because for a and b are positive, then it's satisfying, and you need to check for the differentiability also. Okay, so second function that I am taking is f of x is equal to x square plus 1 and 3 minus x. This is 3 minus x. The x is between 0 and 1, and the 1 is x is between 1 and 2, then it has a value this. Now one should note that this function is continuous or it is differentiable, that you need to check, and you have to check whether we can apply a Rolle's mean value theorem. So for the continuity, it's having the continuity difference is at the 1 because it has a changing its value. Otherwise in this interval it has a polynomial value, and in this interval also it has a polynomial value. So in this interval 0 to 1 it is a continuous function. In this interval 1 to 2 it is a continuous function. But what about at 1? So we need to check for the 1. So for that you need to calculate what is left hand limit, that is limit x tends to 1 plus f of x. But what is f of x at limit is there? That you can say that it is x square plus 1, but x square plus 1 will give me 1 plus 1, which will give you 2, and limit x tends to 1 minus, which gives you right hand limit. So it is x is minus, then the value is 3 minus x, but 3 minus x will give you 3 minus 1 and will give you 2. So that means left hand limit and right hand limit is same at 1. So I can say that this function is continuous at the point 1. It is, and in general I can say it is continuous from the interval. So what I should write here, therefore this f is continuous on closed interval 0 to 2. What about the differentiability? That means I need to check whether the right hand limit of the function f at the point 1 is differentiable, because in this interval 0 to 1 it is differentiable. In this interval 1 to 2 is differentiable because it is a polynomial function. Only the problem is at 1. So that we need to looking at. So this is limit h tends to 0, f of 1 plus h minus f of 1 upon h. But f h is left hand limits, then the function is 3 minus h, so that is limit h tends to 0 will gives you 3 minus 1 plus h minus 2 upon h, so that is limit h tends to 0, 2 minus h minus 2 upon h, which will gives you limit h tends to 0 minus h upon h will gives you minus 2. And left hand limit, that is limit h tends to 0, f of 1 minus h minus f of h upon h, which will gives you limit h tends to 0. Here the function value is x square plus 1, so that's why it is 1 minus h square plus 1 minus 2 upon minus h. And if you apply this h tends to 0 and if you expand this one, then it will left with limit h tends to 0, 2 minus h, and will be gives you 2. So that means this has the value minus 1 and this will have the value 2. So what we can say is this function f is not differentiable at x is equal to 1. So we cannot apply Rolle's mean value theorem onto this function. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in a comment box below. See you in next video. Till then, bye bye, sayonara.